There's beta blockers that are either selective or non-selective, but have you ever thought about how they actually become selective or non-selective? Let's dive into it. Basically, beta blockers can either be selective or non-selective. What that means is they can either be selective to the receptors, or they can be non-selective, meaning multiple receptors. But how do they know what receptors to go to? Like, do they just have a mind of their own? No, it's chemistry. Let's start off with these non-selective ones first. Basically, they're going to be hitting a lot of different receptors other than the ones that are just beta. So all beta blockers will have this basic structure right here, the O, OH, and the amine group right there. R is the aryl group, and the other R on that side just means rest of the molecule. What differentiates between non-selective and selective are these groups over here. Those groups are actually derived from like naphthalene, which is basically two benzene rings put together. Those benzene rings make the drug lipophilic, meaning they love fat. So how they measure how lipophilic a drug is basically through this log D in the blue here. Anything over 1 is considered lipophilic. Anything under 1 is considered either hydrophilic or well balanced. So can you give you an example? Propanolol T up here is 1.41. I'd consider that highly lipophilic. Going to the selective side, if you notice, there's not a lot of rings here in these aryl groups, meaning that they're going to be small and polar relative to the non-polar, which are a bunch of like benzene rings. But Justin, what does it mean if they're lipophilic or hydrophilic when it comes to their selectivity? I'm so glad you asked. Basically, these beta-1 receptors in the heart are a little bit more polar than the beta-2 receptor, which means that the beta-selective drugs like atenolol, metoprolol, stuff like that are going to be more selective with polar molecules because they have a polar group. That's important because if you have a polar molecule, they're going to form better hydrogen bonds or dipole-dipole bonds. And if you know anything about chemistry, those are one of the strongest bonds that you can have. When it comes to these beta-2 receptors are usually located in the lungs, and they're going to be less polar than these beta-1 receptors. It just basically means that these beta-2 receptors are going to be more attracted to these lipophilic molecules like the ones that are non-selective. That's why we have selective and non-selective.